Okay. All right. So the remember this week you were talking about rationalizing the denominator, and so if you if you looked at the videos, and hopefully you are, and I think most of you are looking at those videos. Most of you that are on here right now are looking at those videos that are in Canvas. But remember, when you rationalize the denominator, for example, number one, if you have 5 divided by the square root of, let's say, 10. So rationalize the denominator means that you want the denominator to be a rational number. So the square root of 10 is an irrational number. So that's one of the lessons that discuss that. So in one of the lessons, you discuss the difference between a rational number and an irrational number. Well, the square root of 10 is an irrational number. You want to make it rational. It does not matter if the numerator has a square root in it. You just don't want the final answer to have a square root in the denominator. The easiest way to rationalize the denominator is to multiply the numerator and the denominator by the square root of 10, by the denominator. Now that's assuming that this is a square root down here. If it's a cube root, then it's a little bit different. If it's a fourth root, it's a little bit different, and so on. But the square roots are the easiest to deal with because all you do is just multiply the numerator and the denominator by the denominator. And so notice you have the numerator 5 times the square root of 10, and then you have the denominator, the square root of 10 times the square root of 10 is just 10. I'm hoping you see it's just 10 because the square root of 10 to the square root of 10 is 100. The square root of 100 and the square root of 100 is 10. All right, and that's it. And then you reduce if you can. See, you can reduce here. So 5 into 5 is 1, 5 into 10 is 2. And so you get your answer, square root of 10 divided by 2. And then notice 2 is a rational number. So you no longer have an irrational number at the denominator. So that would be the answer. So that's a process you go through. Then there are some, though, that you may have something like, let's say this. So let's say you had number 2, the square root of 7 divided by the square root of 12. And so you can use the same idea. So there are a couple of ways you can do this. So if you want to get this denominator to be a rational number, you can multiply the numerator and the denominator by that square root of 12. So again, what you do to the numerator, you do to the denominator to get this to be equivalent to this. And so if you look at the denominator, the square root of 12 times the square root of 12 is 12 because that's the square root of 144, which is 12. So notice that the denominator is now a perfect square. I'm sorry, a rational number. But if you look at the numerator, remember one of the properties is that you can multiply the radicands together. When you have a square root of 7 to the square root of 12, using a calculator, and we get the calculator, but using a calculator, you could say 7 times 12, and that would be the square root of 84. So you get the square root of 84 right here. But then you need to simplify this. So one of the things you learned is throughout the topic on radicals is that you simplify as much as you can. So if you look at 84, there is a perfect square that goes in 84, and that's 4. Because if you take 84 and divide it by 4, you get 21. So 4 is the largest perfect square, and the only perfect square that goes into 21 is 1. So that's the largest. And so you're going to rewrite this as the square root of 4 times the square root of 21 divided by 12. And then I can simplify the square root of 4. The square root of 4 is 2. So you get 2 square root of 21 divided by 12, and then reduce. 2 into 2 is 1. 2 into 12 is 6. So your answer is the square root of 21 divided by 6. So I've simplified, even though it said rationalize the denominator, so I did rationalize the denominator, but you need to simplify the radicals as much as possible. And so we simplified. So that's your answer there. Now what some students will do is this. Here's another approach. So you have the square root of 7 divided by the square root of 12. So what they'll do is they'll simplify the square root of 12 first, because they know that the square root of 12 is the square root of 4 times the square root of 3. And so the square root of 4 is 2, so you get the square root of 7 divided by 2 square root of 3. And then if I want to rationalize that denominator, if I want to get rid of that square root that's in the denominator, then all I need to do is just multiply the numerator and the denominator by that square root. Not the 2. Leave the 2 alone. It's this you want to get rid of. So you just multiply numerator and denominator by the square root of 3. And so now notice 7 times 3 is 21, which is what we had here. So you get the square root of 21 divided by, and then the square root of 3 times square root of 3 is 6. I'm sorry, 3, excuse me, 3. And then 2 times 3 is 6. All right, so the square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3, and 3 times 2 is 6. And so you get the same thing. So it doesn't matter what approach you take. All right, so there's number 2. So just a reminder, so if you have something like this, and this was in the lessons in several of the videos, but if you have something like negative 2 square root of 5 divided by 3 square root of 7, then if you want to rationalize that denominator, if you want to get rid of that square root, then only multiply numerator and denominator by that square root. Don't say times 3. I mean, you could, but it's so much easier just to multiply by the square root of 7. And so if you just multiply by the square root of 7 times square root of 7 times square root of 7, which you do to the numerator, you do to the denominator, this becomes negative 2 times the square root of 5 times 7 is 35, divided by 3 times, and then the square root of 7, square root of 7 is 7. So this becomes negative 2 square root of 35 divided by 21. And so that's all you can do there. Now, if you wanted to, just to remind you, so you see the easiest way is just to multiply numerator and denominator by the square root of 7. You could have multiplied, if you think about it, you could have also said, well, I'm just going to multiply numerator and denominator by the denominator. You could. No issue with that. You can definitely do that. All right. And so what's going to happen, though, in the numerator, you're going to have negative 2 times 3 is negative 6. And then you have 5 times 7 squared root of 35 divided by 3 times 3 is 9. The square root of 7 to the square root of 7 is 7. And then notice I can reduce these. In fact, I could have reduced this or this to begin with. But let's just do it here. So you could have reduced these, and so that's going to be, both of these are divisible by 3. So that's going to be 2, that's going to be 3. And so notice you get negative 2 squared root of 35. And then 3 times 7 is 21, and you get the same answer. So again, it does not matter what approach you take. Just know that it's possible to go different paths to get that answer. Just make sure you're doing things mathematically correct and that your work is shown, if it says show work. Then, okay, so then we started looking at something like this. So in number 4, we started looking at something like, well, what if you had 3 divided by 2 plus the square root of 5? Right, so you're going to see something like this on your test at the end of next week. So notice that that's a little bit different than these. So here you only had one term in the denominator. You only had one term in the denominator. Here you have 2 terms. And so you saw that in the videos, in the lessons, that to rationalize this denominator in which you have 2 terms, you really are going to have to multiply both numerator and denominator by the conjugate of this. So that's where we started talking about the word conjugate. So the conjugate of 2 plus the square root of 5 is 2 minus the square root of 5. So you're just changing that middle sign. And so you're going to say 2 minus the square root of 5, 2 minus the square root of 5. And what's going to happen is that if you notice that the denominators, these are conjugates of each other. So if you multiply 2 factors that are conjugates of each other in terms of square roots, you're going to end up with a rational number. So to rationalize this denominator, you're going to multiply this denominator by its conjugate. But what you do to the denominator, you do to the numerator. And so now what happens is this: I have 3 times 2 minus the square root of 5 divided by, and then we're going to FOIL this out. So basically you have 2 plus the square root of 5 times 2 minus the square root of 5. And so if you FOIL, 2 times 2 is 4. The outer is 2 times the negative square root of 5 is negative 2 square root of 5. The inner is a positive 2 square root of 5. And then notice here, a positive times a negative is a negative. The square root of 5 times the square root of 5 is just 5 because it's the square root of 5 times 5 is 25. Square root of 25 is 5. Whenever you multiply a binomial and the middle signs are the only thing that's different, see, these are conjugates. The outer and the inner will always cancel out. So you have a negative 2 square root of 5 and a positive 2 square root of 5. That's 0. And so all you have is 4 minus 5, which is a negative 1. So that's your denominator. Now the question, so rationalize the denominator. See, now it's a rational number. There's no longer a square root. But you don't leave it like this because you can write this in a better way. So the fact that the denominators are negative 1 means that if you cover up, let's see, if you cover up this little part here for right now, this part here, you know that 3 divided by negative 1 is a negative 3. So if you want to, you can write this as negative 3 times 2 minus the square root of 5, and then distribute. So I get negative 6, and then negative times a negative is a positive, so you get negative 6 plus 3 square root of 5, and that's the answer. So remember, if it's a negative 1 in the denominator, then you can easily rewrite it like this, and that's what you want to do. Now, it's not always going to be negative 1. So for example, if we do this for number 5, where you have 4, let's say, divided by 3 minus the square root of 7. So if you want to rationalize the denominator, meaning you want to get rid of that square root because the square root of 7 is an irrational number, so that makes this whole thing irrational. You're going to multiply both numerator and denominator by its conjugate, so 3 plus the square root of 7. And so the numerator becomes 4 times 3 plus the square root of 7. And then you just got to figure out what the denominator is. So you have 3 minus the square root of 7 times its conjugate. And so when you FOIL that out, 3 times 3 is 9. The outer is a positive 3 square root of 7. The inner is a negative 3 square root of 7. And the last, a negative times a positive is a negative. And then square root of 7 is just 7 because it's the square root of 49. Notice these cancel out. That's 0. A positive 3 squared is 7, and a negative 3 squared is 7 is 0. And you get 9 minus 7, which is 2. So that's 2 right here. But then sometimes, now notice, you want to ask yourself, can I do anything before I distribute? Because you eventually want to get rid of the parentheses. So if I cover up this part here, you're going to notice I can reduce the 4 into 2. So this is going to be 1, and this is going to be 2. So I get 2 times 3 plus the square root of 7. And then you distribute, and so you get an answer of 6 plus 2 square root of 7. And so that's your answer. If you look at number 6, let's say you had this instead, number 6. You had 8 divided by, so let's say was the, let's say 2 minus 3 square root of 5. All right, 2 minus 3 square root of 5. So if you go ahead and, I'm going to go ahead and rewrite this. So remember, you want to get rid of the square root that's in the denominator. So you'll multiply numerator and denominator by the conjugate. So the conjugate of this is 2 plus 3 square root of 5. And so now we're going to write this as 8 times this. 8 times 2 plus 3 square root of 5 divided by, and then you just go off to the side and figure out what this product is. So 2 minus the square root of 5, 3 square root of 5 times 2 plus 3 square root of 5. All right, so this time you get 2 times 2 is 4. The outer, 2 times 3 square root of 5 is 6 square root of 5. The inner, a negative 3 square root of 5 times 2 is a negative 6 square root of 5. Remember, these are conjugates, so the out and the inner are going to cancel out, and they do. A positive 6 square root of 5 and a negative 6 square root of 5 is 0. And then the last, a negative times a positive is a negative. 3 times 3 is 9 times the square root of 5 times the square root of 5 is 5. So this becomes 4 minus, and then 9 times 5 is 45, so it becomes a negative 41. So that's your denominator, negative 41. Now, if you cover this part up and then ask yourself, can I simplify this? You cannot. Now, if you want to put the negative out in the numerator, you can. So in other words, you can say negative 8 times 2 plus 3 square root of 5 divided by 41. Just notice those are the same thing. But in the end, you want to go ahead and distribute this. So your answer is going to be 16. 8 times 3 is 24. Square root of 5 divided by negative 41. So that's one answer. For this one, you would say negative 8 times 2 is a negative 16. A negative 8 times a positive 3 square root of 5 is a negative 24 square root of 5 divided by 41. So either one's fine. Either one's fine. So then he also saw in some of your lessons that you in the numerator, you saw in the numerator in all these problems, there was just one term. You could have two terms up here and two terms down there. So let's kind of review how to deal with that. So if you had 2 plus the square root of 6 divided by 3, let's say, minus the square root of 2. Let's say you had that. So again, you want to rationalize the denominator. So it's okay to have a square root in the numerator, you just don't want it in the denominator. And so what you're going to do is rationalize the denominator. So if you rewrite this over, you're going to say, you're going to multiply both numerator and denominator by the conjugate of the denominator. So the conjugate of 3 minus the square root of 2 is 3 plus the square root of 2. And so now notice you're going to be foiling both cases. See, in the first one, it was a one term times a binomial, so you just distribute it. Here, you have two terms times two terms, so that's where you're going to FOIL. So let's go ahead and do that work. So in the numerator, we have 2 plus the square root of 6 times 3 plus the square root of 2. And so if you FOIL, you get 2 times 3 is 6. The outer, 2 times the square root of 2 is 2 square root of 2. The inner, square root of 6 times 3 is 3 square root of 6. And the last, a square root of 6 times the square root of 2. So remember, square root of 6 times the square root of 2 is the square root of 12. So that's going to be plus square root of 12. All right. Now simplifying what we can. So let's see. These are not like terms because this is the radicands are different. But I can simplify the square root of 12, and you want to do that. So this right here is going to become 6 plus 2 square root of 2 plus 3 square root of 6, and this is plus, and remember the square root of 12 is the square root of 4 times the square root of 3, so that's 2 square root of 3. And then notice there are no like terms, so that's going to be your numerator. So your numerator here is going to be this, all those four terms. You can't combine anything, they're all different. So 6 plus 2 square root of 2 plus 3 square root of 6 plus 2 square root of 3. Now the denominator, those are conjugates. So you know when you multiply these, since those are conjugates, you're going to get one number down here. That's what you're going to get. One term, and it's going to be a rational number. So let's go ahead and multiply that out. So you get 3 minus the square root of 2 times 3 plus the square root of 2. And so when you FOIL, 3 times 3 is 9. Now remember, these are conjugates, so the outer and the inner are going to cancel out. So really all you're looking at is the first and the last. That's all you're doing. And so if you look at the last now, a negative times a positive is a negative. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So this becomes 7. And so this is 7 down here, and that's all you can do. You're done. And so it's number 7. All right, and then in number 8, suppose we had this number 8. So in one of the lessons, you had variables involved. So let's look at one where we have variables. So this could be number 8. So let's suppose, and I don't want to, let's see, let's try this one. So let's suppose you had 6 divided by 3 plus the square root of x. So 6 plus the 6 divided by 3 plus the square root of x. It's the same approach. You want to get rid of that square root, so you're going to use the conjugate of this. Since you have two terms, you're going to do the conjugate. So you're going to get 6 divided by 3 plus the square root of x, and you can multiply the square root of x. then you can multiply both numerator and the denominator by the conjugate. So the conjugate of 3 plus the square root of x is 3 minus the square root of x. And so now notice you have one term times 2, so you can use the distributive property here, but first of all, I'm going to rewrite it like this. All right, now in the denominator, I'm going to multiply those two binomials out. So just go off to the side and kind of deal with it that way. So remember, those are conjugates. So when you FOIL, you get first times first, 3 times 3 is 9. When you FOIL, though, remember the outer and the inner add up to be 0, because those are conjugates. And it makes sense because when you look at the outer, 3 times the negative square root of x is a negative 3 square root of x. The inner is its opposite. A positive times positive is a positive. And so notice those add up to be 0. Now over here, so when you look at the last, a positive times a negative is a negative. The square root of x times the square root of x, remember the square root of x times the square root of x is the square root of x squared. But you know how to simplify this. The square root of x squared is just x, because x times x is x squared. So that's just x right here. And so now this becomes just 9 minus x, and that's your denominator. And if you remember, we did this, and you say, can you simplify this? Now, this is where some students mess up. They say, oh, I can simplify the 6 and the 9. No, you can't, because you're subtracting x. That's not 6/9 here. That's 6 divided by 9 minus x. So if that wasn't there, then you could. But the fact that you have that this is 9's not a factor anymore. 9 minus x is a factor in the denominator. So don't make the mistake and reduce the 6/9 here. So the only other thing you can do is just distribute, and then you're done. So you get 6 times 3 is 18, and then 6 times the negative square root of x is 6 square root of x divided by 9 minus x. And that's all you can do. That's all you can do there. All right, so let's look at another one with a variable. So let's look at this one. So let's suppose we had this. So we had, let's do the square root of x, I'm making this up, square root of x divided by 2 plus 3 square root of x. So let's suppose we had that. So again, you have a square root of the denominator. You don't want a square root of the denominator, so that's why you rationalize the denominator. But it's two terms. So to rationalize a denominator with two terms, you're going to use a conjugate. And so the conjugate of this is 2 minus 3 square root of x. So I'm just going to rewrite this over. And so I'm going to multiply by the conjugate. So 2 minus 3 square root of x, 2 minus 3 square root of x. And so I'm going to get the square root of x times 2 minus 3 square root of x. And then I just go off to the side and multiply this out. So remember, those are conjugates. So you're going to have 2 plus 3 square root of x times 2 minus 3 square root of x. And when you FOIL it out, remember these are conjugates. So when you FOIL, 2 times 2 is 4. The outer and the inner are going to cancel out. And if you got it right out, you write it out. So notice 2 times a negative 3 is a negative 6, and you get square root of x. 3 times 2 is a positive 6 square root of x. So you see they cancel out. Now with the last, you got to be careful. So here's your last right here, the last terms. A positive 3 times a negative 3 is a negative 9. And then the square root of x and the square root of x, we saw a while ago, is square root of x squared, which is x. So this is just 9x. So this times this is just a negative 9x. And then you get 4 minus 9x, and that's all you can do. So this becomes 4 minus 9x. And so you cannot reduce these, so then you can distribute. So when I distribute, I get the square root of x times 2 is 2 square root of x. And then let's think about this right here. So you have the square root of x times a negative 3 square root of x. So you have the square root of x times a negative 3 square root of x. All right, so this becomes a negative 3 square root of x times the square root of x. And remember, the square root of x and the square root of x, we already talked about that. That's this. That's square root of x squared. So you get negative 3 square root of x squared, which is negative 3x. So up here, you're going to have minus 3x divided by 4 minus 9x. And that's all you can do. You cannot do anything else. And now notice you did rationalize the denominator because you no longer have a square root. It doesn't look like a rational number, and it's not because it's a variable expression, but you don't have a square root in the denominator anymore. So you rationalize the denominator. All right, so number 10, you're not going to have one like number 10 on the test, but you may, I think it may be on a worksheet, or it may look like something on a worksheet or a My Math Lab. But let's suppose you had this. And the reason you won't is because it's going to take too long, and there's so many places where you could easily mess up. So let's suppose in number 10 we had this, 2 plus the square root of x, square root of x, divided by 3 minus the square root of 2x. All right, so let's suppose we had that. And so you want to get rid of that square root that's in the denominator. And so you're going to, I'm just going to go ahead and rewrite this over. All right, so remember the first thing you got to do is ask yourself, what is the conjugate of the denominator? So the conjugate of the denominator is 3 plus the square root of 2x. 3 plus the square root of 2x. And then you're going to notice you have two terms times two terms. So that's where you're going to put those in parentheses. So in other words, you're going to write it like this. You're going to say 2 plus the square root of x times 3 plus the square root of 2x divided by, and then the same thing in the denominator. 3 minus the square root of 2x times 3 plus the square root of 2x. And then you're just going to FOIL out. So let's go off to the side and kind of do that work in the numerator. So the numerator, remember, is this. It's 2 plus the square root of x times 3 plus the square root of 2x. And so if I FOIL, 2 times 3 is 6. The outer is 2, a positive and positive is positive, 2 square root of 2x. The inner is 3 square root of x. And the last, now be careful with the last, you have the square root of x times the square root of 2x. So think the square root of x times the square root of 2x. According to the product rule, that's the square root of 2x squared. But I can simplify the square root of 2x squared. That's just x. So this right here becomes x square root of 2. That's where it comes. Now I want to mention some of you are doing this. So you got to be careful, and I graded some stuff today and submitted it. So if you didn't get a 10, you may have got a 9.5 for this reason. Some of you wrote this like this, and you have to be careful. So you said this. So when you write this, even though you mean this is not supposed to be under the square root. So if it looks anything like the x is under the square root and it's not supposed to be, you're not going to get full points. So and I've told you in the lessons before, I've always said this, to be on the safe side, put the variable x on the front end. Don't put it on the back end, because some of you are writing it to look like this, and to me it looks like x is underneath. You may say it's not, but to me it looks like that. So to be on the safe side, put that on the end if it's supposed to be on the end. Okay? So I'm just letting you know that some of you are still doing this, and so you're putting it so close to the square root that it looks like it's underneath. So if you want to put it behind, then you got to make sure it looks like this. You see, I can tell that x is not under the square root. So be careful. All right, so that's going to be plus x squared root of 2. All right, and then notice there are no like terms. Now be careful, don't say that these are like terms, because remember, when dealing with square roots or radicals, the indices have to be the same, which they are. Square root to the index here is 2, the index here is 2, but the radicands have to be the same. The radicands are not. This is a 2x, this is just an x. All right, so there are no like terms here. So when I multiply this out, that's just this. So that becomes 6 plus 2 squared root of 2x plus 3 squared root of x plus x squared root of 2. All right, and then notice there are all kinds of places you could have easily messed up. And then the denominator, remember those are conjugates now, so that's going to be a little bit easier to deal with. Let's see. So when you fall, remember those are conjugates. So when you fall out, you get 3 times 3 is 9. The outer and the inner cancel out. Those are conjugates. They add up to be 0. So all you have left then is this. A negative times a positive is a negative, and you have the square root of 2x times the square root of 2x. So if you think about it, the square root of 2x and the square root of 2x, and there are several ways you could do this. You know that that's the same thing as saying the square root of 2x to the second power, and then 2 divided by 2 is 1, so that's just 2x. Or if you want to, you could have done this. The square root of 2x and the square root of 2x is the square root of 2 times 2 is 4. X times x is x squared. And then notice that this becomes the square root of 4 times the square root of x squared, which is just 2x. All right, so either way is fine. You get the same thing. So this becomes 9 minus 2x, and there's nothing you can do here. Those are not like terms, so you're just going to write it here. And that's it. That's your answer. That's all you can do. All right, so that was a quick review of the information for this week, and with regards to let's go back to that page where we were rationalizing the denominator. So on your test though, on your test coming up, you will have one where you're gonna have two terms you're gonna have to rationalize, okay? And you are gonna have one where you could have a variable as well. All right, so make sure you can do that. I am not going to ask you to do where you have 2 up here, 2 down there, because it just takes too long, and you could easily mess up. So I'm not going to ask that. So I am going to ask you though where you're going to have one term up here and a binomial. All right. So just make sure you can do 1 through I guess 1 through 6, and the rest were 2 binomials. So 7, 2 terms divided by 2 terms, and 8. Well, 8 was 1, so you should be able to do 8. You should be able to do 9. All right. But as with regards to keep losing these pages, but regards to 7, I'm gonna put a little star there. 7 and 10, I'm not going to ask, only because you have 2 terms divided by 2 terms, and it's just going to take too long. All right, so that make sure you can do that on your test. Okay, all right. So that was that was rationalizing the denominator, and that was one of the things you did this week.